and you're looking for a probability that a point randomly chosen will be picked from the shaded region. Okay, so there's, again, a couple ways to attempt this problem. I'll go through both of them. Okay, it says assume the diameter of each consecutive concentric circle is 2 feet longer than the previous one, and the diameter of the middle one is 2 feet. Okay, what does that mean its radius is for that middle inside one? 1. Okay, so the inside one has a radius of 1 foot, and as you kind of extend out, each consecutive ring has 2 foot diameter difference. So what's its radius difference? 1. So the next one's going to be a radius of 2 feet, and the final one's going to be a radius of 3 feet. Okay, so those are the 3 measurements that we're looking at. And so if you're looking for the total probability, it's going to be the shaded region divided by the total possible region. Well, in picture form, the shaded region is found by taking the large circle and subtracting the middle circle from it. And then, like with all of that, it also involves adding this inside small shaded region. And you're going to divide that by the total. So the shaded and unshaded all combined is just the large circle. And so visually, here's what we're looking at. And so if we find the values for these, the area of the large circle is pi times 3 squared, or 9 pi. The area of the inner circle is pi times 2 squared, or 4 pi. And the small circle is pi times 1 squared, or 1 pi. So when you're looking at this, if we plug these in, we get the total probability is 9 pi minus 4 pi, and then that whole thing added to 1 pi divided by 9 pi. And so if we plug in our values for those, we can now just simplify what we have. 5 pi plus 1 pi gives us 6 pi over 9 pi. The pi's cancel. We can reduce our fraction. 3 goes into 6 twice. 3 goes into 9 3 times. And so we get our probability to be 2/3 for that. Okay, so that's probably the way that most of you would see this problem. And there's a second way to approach this problem, again, is if you can see ratio of parts and areas, then you might be able to solve this a little bit quicker, because when you're looking at this, if we take the small circle compared to the large circle, what is the ratio of their parts? 1 to 3. What does that mean the ratio of their areas is going to be? 1 squared to 3 squared, so 1 to 9. And then if we look at the ratio between the parts and areas of the middle circle compared to that last circle, the ratio of their parts is 2 to 3. The ratio of their areas is 2 squared to 3 squared. And so if you look at that relationship, what you can do to find the probability is the whole thing is 9, right? So there's 9 total parts in this whole thing. We see it in both of these cases. If we remove the white part from it, we're removing how many from 9? The relationship is the white part represents a ratio of 4 to 9. So we're going to remove 4 of those parts. So how many would we be left with? So just this shaded ring right here represents 5/9 of the whole thing. Well, then we have to add this small part back in. The small part represented how many ninths? 1. So if we take 5/9, the ring, and we add 1/9 to that, we get a total of 6/9, which reduces to our 2/3. So you can still solve this by using ratio of parts and areas, and that doesn't involve these calculations.